Good afternoon, girls. Today I will teach you the exercise 8.4 in trigonometry, which is based on the identities. Okay, we have done identities sine squared theta plus cos squared theta is equal to 1. 1 plus tan squared theta is equal to sec squared theta. Then we've done cot squared theta plus 1 is equal to cosec squared theta. Then we also completed one or two questions from the exercise 8.4 and today I will teach you question 4 and question number 5, right? Question 4 says, choose the correct option and justify your choice. The first question is 9 sec square A, 9 sec square A minus 9 tan square A. Now the questions which are given in question 4, the type of questions which are given here in the exercise, you have to either prove left hand side to be equal to right hand side, or if you have to choose the correct option, then you have to first you analyze the question what has to be done. Don't just simply start solving without looking what has to be obtained, right? So if any type of such question is given to you, first you just 2 or 3 seconds you analyze the question properly, which identity we can apply here, and then you proceed with the solution. So over here what I can do is 9 sec square A minus 9 tan square A is, I know that there is a relation between sec square A and tan square A. So what I'll do is I will change either sec square A or tan square A in terms of the other. So let us do this. 9 for sec square A I can write 1 plus tan square A and here minus 9 tan square A. Okay, so as you can see that we can multiply this 9 plus 9 tan square A and minus 9 tan square A. So these two terms, as you can see, that they are similar with the opposite signs, and therefore we can cancel them, and therefore I get 9 as the answer. So out of the 4 options which are given, 1, 9, 8 and 0, we can choose the second one, and this is the justification of the choice, that why we have chosen 9, because when we solve we get the answer 9. So therefore in choose the correct option, you have to first solve the question completely and then find out which option fits the which is the right option for you. Then one more I'll do for you, and that is second one or third one. Third one, let me do the third one. Sec A plus tan A. Sec A plus tan A and multiplied by 1 minus sin A. We can solve this by multiplying the two brackets or the two binomials. We will write sec A into 1. So I'll multiply sec A into 1, which will give me sec A. Sec A into sin A, that is minus sin A sec A. Okay, sec A into minus sin A will give me minus sin A sec A. Then tan A into 1 will be tan A, right? And tan A into minus sin A will be minus sin A tan A. Okay, now let us continue. We can solve sec A, tan A and tan A, right? So what we can do, we write 1 upon cos A minus sin A upon cos A. 1 upon sec A means 1 upon cos, and this cos I merge with sin A, then plus sin A upon cos A and minus sin square A upon cos A. I hope you followed. Why sin square A? Because tan A is sin A upon cos A, and sin A I multiply by sin A, I get sin square A. Okay, so now the LCM over here will be cos A, 1 minus sin A plus sin A minus sin square A. So yes, so this will cancel. I have now minus 1 minus sin square A upon cos A. Now you know that identity 1 says 1 minus sin square A is equal to cos square A. So therefore here I can write cos square A upon cos A, and therefore cos A into cos A upon cos A, out of which one will cancel, and therefore the answer is cos A. So the correct option is, the four options are sec A, sin A, cosec A, cos A. So therefore the fourth option is correct, and this is how we have proved, or this is how we have justified our choice. Okay, so these type of questions are given in question number 4 and 5 in the exercise 8.4. So as I told you that you first analyze the question and then start solving. Uh, Question number 5 says, prove the following identities where the angles involved are acute angles for which the expressions are defined. So I'll take up an easy question in the fifth one. Again, you have to prove. All these sums you will do in your notebook. I hope you are completing your work and studying regularly. So let's start with question number 5. And in the fifth question, I will do the first one also I'll do. Let us do the second one. In the second one it says cos A upon 1 plus sin A, right? Cos A upon 1 plus sin A plus 1 plus sin A upon cos A. Okay, we have to prove it to be equal to 2 sec A. So as you can see that there are two parts of this question, left hand side and right hand side. When we start solving one side, we have to prove it to be the other side, or we can sometimes we can solve both simultaneously. So let us begin with the LHS, that is the left hand side here. Okay, we can see that the LCM will be 1 plus sin A and cos A. So the LCM of this will be cos A into 1 plus sin A. Then 1 plus sin A, when I divide this by this, I'll get cos square A. And when I divide this by this, I get 1 plus sin A the whole square. Okay, cos square A plus, I will solve this identity. This identity is A plus B the whole square, and that will give me 1 plus 2 sin A plus what? Sin square A. Okay, so this is the identity upon cos A. Okay, cos A and here 1 plus sin A. Right? Now I can see that cos square A and plus sin square A is equal to 1. So therefore I can write 1, this 1 and 1 will give me 2. So I will get 2 plus 2 sin A. Okay, and upon cos A into 1 plus sin A. I hope you followed what I said. Cos square A plus sin square A is equal to 1, and this 1 plus 1 is equal to 2, and 2 plus 2 sin A upon cos A 1 plus sin A. Now here you can see that 2 is common. 1 plus sin A will be in the bracket, right, upon cos A into 1 plus sin A, right? You followed what I said? I will take out 2 common. And I will write 1 plus sin A upon cos A into 1 plus sin A. If you can't see my handwriting, you can at least listen to me what I am saying. You can cancel 1 plus sin A and 1 plus sin A, and therefore I get 2 upon cos A. What is 1 upon cos A? 1 upon cos A is equal to sec A, and therefore I can write it is equal to 2 sec A, and that is given in the right hand side. Hence, the solution is correct, and we get left hand side is equal to right hand side, and then in the end we write hence verified or hence proved. Okay, so as I told you that first analyze the question and then start solving. Okay, so I hope this is clear to you. Cos A upon 1 plus sin A and 1 plus sin A upon cos A, we find the LCM. Then after finding the LCM, we solve for the numerators. As we get the numerators, here I apply identity 1 plus sin A the whole square, that is A plus B the whole square, and then I merge with this sin square A and cos square A, which is equal to 1 with 1, which gives me 2, and 2 plus 2 sin A will be equal to 2 common 1 plus sin A, which cancels with the denominator, and therefore I get 2 upon cos A, which is equal to 2 sec A. Okay, so this is how we have completed the second part of question 5. You will copy these questions in the notebook and solve them. and learn all the identities thoroughly. Okay, now one more sum is, there are many sums here, total 10 questions are there. So I can do one more, fourth one, it will go fast. 1 plus sec a upon sec a plus, no, is equal to sine square a upon 1 minus cos a. So we have to prove that one side, left hand side, is equal to right hand side. We can start from any side as we want, but let us begin with the LHS. Now in the LHS side, we can write 1 plus 1 upon cos a upon 1 upon cos a. Okay. Therefore now what? Cos a plus 1 upon 1 upon cos a, and this is also upon cos a. Right, so I hope you're following. We find the LCM here and then the denominators get cancelled. So here I get cos a plus 1, which I can also write it as 1 plus cos a. This is LHS. Now I can also solve the right hand side, sine square a. Sine square a I can write 1 minus cos square a upon 1 minus cos a. 1 minus cos square a means a square minus b square. 1 minus cos a upon 1 plus cos a. Identity number 3, which we've done in class 8th also, which cancels with the denominator, and therefore in the right side also I get 1 plus cos a. And therefore 1 plus cos a and 1 plus cos a, LHS is equal to RHS. So these type of sums are given. Try to solve them, and one or two questions I have explained you. There is a proper analyze them, check them how they have to be done, and then start solving.